there are three cases we consider in the area ratio related questions. Number one case is related to similar triangle. Okay, so for example, this is the figure given to you, and you know the ratio of side, corresponding side. You know the meaning of corresponding side. OC and OA are corresponding sides for the triangle OCD and OAB, right? So this is the case number one. If the triangles are similar, and question is asking you to find the numerical value of for the area of OCD, mean this area, and OAB, sorry, this is B, OAB, okay, OAB, then you will see what are the corresponding sides in this triangle and in this triangle. So it is 2 and it is 4. So you will write 2 over 4 and square it. So 2 over 4 you can simplify and then square it. So the ratio is 1:4. So what you have to remember here, that if the case is of similar triangle, you will take the ratio of the corresponding side and square it, right? Okay, number 2. Whereas if question says OCD triangle and ABCD. Now ABCD is this portion, okay? So now question is saying what is the ratio of this area with this area? So you have to take help of the similar triangle. In the similar triangle, this ratio was 1 area and this whole was 4. So if I have to find this, I will do 4 minus 1. Yes? So when I will find out the ratio of this, I will do 1 over 4 minus 1. So to do this step, you have to find out ratio of similar triangle first of all. Only then you will be able to do it, and you will not square it now. Remember this thing. So first case is done, which is about the similar triangle. Now the case when it is a common height. I will explain 3 cases first, and then I will pick up one question in which I will consider all the cases, right? Okay, now look at this triangle. Okay, forget about this line for the time being. If you remember, if you have to find out the area of this triangle, right, this will be base and this can be taken as a height, because if you extend this base outside, then height is making here 90 degree. So to find the area of this triangle OAB, you can do half into height into 2. And similarly for triangle OCB, if you have to find the area of a triangle, you can write half into height into CB. CB is 3. So if you see, when the big triangle is divided into 2 parts, I'm not using the word equal, okay, in any with any ratio. If the big triangle is divided into 2 triangles and it has common height, then what you will do to find the area of OCB and OAB. Now I'm showing you in detail here. It is half into height into CB, half into height into CB, and OAB will be half into height into BA, which is 2. So I'm writing this, half will cancel out, height will cancel out, and 3 over 2 will be left behind. So what you have noticed here, okay, in case of the area of a numerical value for the ratio of the area of triangles which share the common height, you just pick up the bases. So what were the bases here? 3 and 2. So this will give you the ratio of the area of the triangles. In common height, we were picking up the corresponding sides and squaring it, right? Here we are picking up just base side and then writing it as it is. Now look at this question. Now question is saying OCB, OCA, OCB, OCB, OCA. So now question is saying the ratio of this area with respect to this whole area. Again, it is sharing the common height. Why? If you look at this triangle, the height is H, base is CB. And if you look at this big triangle, the base is this CA, which is 5, and height is this. So if you write here Now this step I'm writing to explain to you. You do not need to mention it if you don't want to. There is no harm. So half into height into CB, half into height into CA. The height was common, cancel out. These are the values given there. So your area numerical value, ratio of the area of two triangle will be 3/5. So now let's see the last case where we apply chain rule. Okay. Now look at this triangle. E is the midpoint. Okay. Now for example, question says area of AOC, this area, and AOB, this big one. So basically this is small, ratio of this is small with the ratio of this big one. Right now there is no connection between the big one and this one. There is no common height, it's not similar. So in that case you apply rule of chain rule. How? Now first of all see here, then I will show you the solution. If you look at this triangle and if you look at this triangle, can you see the common height is between them, which will be somewhere here because height will be perpendicular. So this triangle and this big triangle are sharing common height. And if I see AOB, which is this one, this triangle also sharing common height between this one and big one, the one I have just explained in the previous case. So I can say here, just showing it from distance so that you can see the diagram at the same time, AOC over AOB is equals to AOC and AOE. So I'm writing this triangle with this one and then this triangle with the big one. If you find it difficult to understand, you can pause the video here and try to draw and write it yourself, then it will make more sense to you. So after writing this connection, if you see this one, the numerator is here and this denominator is here. This is the common one between them. So whatever the sides ratio will be given in the question, I will write them down here and then I'll multiply it, I will get this ratio. So we will see the actual application in the question. So I have picked up one question. It is from the past paper, but I have edited a little bit so that I can explain all three concepts of the area ratio vector with one question. So I did not mention the year. Okay, so the question was that this diagram is given to you in the question and the values written on it are also given to you. So it is given that OP is B, vector B, arrow is telling you in this direction, and OS is 3B, PS is 2B. It is also given that ST, PQ and OR, they are parallel. This is given to you, it is 2A plus B, A and B are your vectors, right? And this is 3A, okay? And it is also given that OS, OT and RS are a straight line. So first part of the question was saying find out these vector in terms of AB. So vector PQ is equals to PO plus OQ, right? So to find out PQ, I'm simply doing PO plus OQ. Because it is in the opposite direction, so I'm writing minus B. And OQ is 2A plus B, so I got 2A. Then question is saying find out QR, this vector. So can you think what you will do? To find out QR, you will do this, QO plus OR. I'm taking help of the diagram right now. So QR is QO plus OR. Because OQ is given to you in the question, QO will be opposite direction, so minus sign, simplification, and you get A minus B, right? So you have found what is PQ, you have found what is QR. So you know QR, it's this direction. Directions are very important. So now let's find out what is QT. QT is this vector. Okay. So now we have to find out what is QT. Now if you see here, to find out QT, what path I take. If I take this path, I don't know ST. So for here you will use the ratio similar triangle concept. You know, that's why this part was little challenging for a student in that year. So if you see triangle OPQ and OST are similar. So if I see the ratio of this side with this side is similar to this side with this side. Okay. So we know the ratio here. I'm not talking about AB. AB are vectors, just the ratio in terms of numbers. So this is 1 and this whole is 3. This I don't know and this I don't know. So let's see here. So I'm writing OQ over OT means OQ over OT is equals to OP over OS. This is what I'm writing here. OP was 1 and OS was 3, right? So you see, I'm not writing vector right now because I'm talking about magnitude. I'm talking about size. So vector symbol is not here at the moment. So OT is equals to 3OQ. Fine. Now after that I'm using vector symbol. That vector OT is equals to 3 times vector OQ. Why? Because your OTQ is on the straight line. So then you are substituting the vector OQ and hence you found OT, which is 6A plus 3B. Does it make sense? So now the last part of the, now you will plug in the value because the question was originally find out QT. So to find out QT, now I know OT and I already have OQ. So what will I do? I will do OT minus OQ. It will give me QT. So I'm just plugging in values now here. I'm plugging in the value of OT and OQ, simplify, I get this. So this is how I got QT. Now I have to find out ST. Again, see the diagram. To find out ST, you can do SO and OT. So you have SO, which is minus 3B because it is in the reverse direction, and OT you have just found, which was 6A plus 3B. So let's substitute here. So I have substituted the values here, simplified it, I got 6A. Now the question is coming to the ratio. Why did I solve part 1? Basically, I want to show you that in most of the question, the ratio of all the sides is not given to you. So first part is always to find it out and the remaining answer based on it. Now question is saying find out the numerical value of the ratio of the area OPQ and SPQ. So I have drawn the part of the diagram here again. This was given in the question. If you want to see, I can show you here. It is basically about this part of the question because it is saying OPQ and SPQ. So I have drawn this part of the diagram here to show you. Because if diagram will be in front of you, it will be easy to understand. Okay, so now if you look at this triangle, question is talking about this part and this part. So you can easily connect it that it is a case of common height. So if you draw height from here, this will be height, this will be base, and for this triangle, this will be height and this will be base. B is just telling you a direction of the vector, so we will not write that in numerical value of the ratio of the triangles. So I'm writing 1 over 2. Fine. Now if the question says PQS, it means this one with this OQS, the biggest one. So before I show you the answer, can you tell me what is the ratio of PQS with the ratio of OQS? Yes, you are right. It is 2 over 3 because height will be again common. Okay, so let's see the other part of the question. So I have drawn the diagram here again. Now the question is saying area of OPQ, mean this triangle, and OST, the big triangle. So before I show you the solution, can you tell me what case is this? The previous case was common height and this is a case of, yes, you're right, similar triangle, OPQ and OST. And what did I tell you? What do you do in case of similar triangle? You pick up the corresponding sides, ratio, and square it. So for this triangle, it is 1 And for this big triangle, it is 3 because 1 plus 2 is 3. So you will take 1 over 3 and you will square it. It will be 1 over 9. So we have done common height, common similar triangle. Let's see if these concepts will apply in the next part or not. Okay, so now the question is saying the ratio of area of OPQ and triangle ORQ. What is OPQ? This is OPQ and this is ORQ. So let me draw this part of the question here. By the way, I have written this because I found this answer in part A, which is 2A. This was given. Okay. Now question is saying find out the area of OPQ and ORQ. So this ratio with this. Now if you see, it doesn't look like immediately a common height, but actually it is. Because these two lines are parallel, okay? If I extend these lines, then perpendicular distance between them is same everywhere. And that perpendicular distance is basically your height for this triangle, which has this base and this height. Similarly for this triangle, this is your height and this is your base. Make sense? So if question says find out the ratio of the area of OPQ and ORQ, you will see they both share common height. So if you write the formula, it will be half into height into 2A, and this will be half into height into OR, which is 3A. So basically the bases are 2 and 3 because A is just a vector, so we will not consider it. So the numerical value of the ratio of the area of OPQ and ORQ will be 2 over 3. I hope it is clear. So now let's see the last part. Now question is saying the area of SPQ and OQR. Now what is SPQ and OQR? Let's see the diagram. Here, this is SPQ and this is OQR. So before I show you the solution, can you see what you will do here? Because directly there is no connection between them. Yes or no? So we will apply chain rule. You are right. So this connects with this because they are sharing common height. We have done in part 1. Similarly, this and this also connect common height. Share common height. So there is a connection between them. Sorry. So this triangle is a common thing between them and them. So we will make a chain rule of this triangle with this and this triangle with this. So how will I write here? I will write SPQ over OPQ, showing you SPQ over OPQ, and then OPQ over ORQ, which is OPQ over ORQ. After that, if you see here, the ratio is 2:1 because the common height is here. For this triangle, base is 2B, and for this triangle, height will be the same. It is 1, right? So 2 and 1. So I will write 2 over 1, which I have written here. SPQ over OPQ is 2 over 1. And then I'm writing OPQ and OQR or RQ, ORQ doesn't matter. So I have just found in the part 1, which was 2 over 3. Now remember, ORQ and OQR is same triangle. Order matters when you're talking about similar or congruent triangle, right? Here I'm talking about ratio of the triangles, so it doesn't matter. So ORQ and OQR is same thing. So after substituting the values, I got 4:3. So the answer of this is 4:3. Thank you very much for watching this video. With this, it completes all the cases of the area ratio related vector questions. So if you like it, it helps you to learning, please press like and subscribe button. It will help you to get indication of my next videos. Bye bye. Allah Hafiz. Take care.